Chapter 4.7, Least Common Multiple. So, your vocab for today is multiple, common multiple, and least common multiple. The main thing to remember is that a multiple gets bigger, to multiply. Common multiple, something they have in common. Least common multiple, the smallest number that two factors have in common. So we're actually going to turn the page here because I got example 1 and 2 backwards. We're going to find the least common multiple of 4 and 6. So the first method is going to be using the list method. We're simply going to list all of the multiples of 4 and 6 until we find ones that they have in common. So we always start with itself, 4, 8, 12, 16, 20, etc. These are all of the multiples. They are getting bigger. 4 goes into all of these numbers evenly. If I take 6, I have 6, 12, 18, 24, 30. I'm actually going to go do one more in 4 really fast and do 24. So you will notice that 12 and 24 are both considered common multiples. So the common multiples of the ones we've listed so far are 12 and 24. 4 and 6 go into both of these numbers. However, the least common multiple, or the LCM, is 12. It is the smallest of the common multiples. So creating a list is one way to find the least common multiple. This works well if you're using 2, maybe 3 numbers, and the numbers are relatively small. The numbers are fairly small numbers. Using a list works well. However, we're going to go over here to example 2 and take a look at this one. So a train for each of the train lines shown in the table on the left has just arrived. In how many minutes will a train for each line arrive again at the same time? So here we have the yellow line. So the yellow line arrives every 8 minutes. The green line arrives every 10 minutes. And the purple line arrives every 20 minutes. So what I'm going to do for this one is I'm going to use prime factorization. I could make a list, find prime factorization. Can't talk and spell at the same time. I could make a list, but what I would like to do instead is use prime factorization. So 8, I'm going to use the ladder method. The smallest prime is 2. 8 divided by 2 is 4. Smallest prime is 2. 4 divided by 2 is 2. Smallest prime is 2. 2 divided by 2 is 1. So I'm done. So we'll go ahead and color code this. 8 equals 2 times 2 times 2. Green line is 10 minutes. Smallest prime is 2. 10 divided by 2 is 5. Smallest prime is 5. 5 divided by 5 is 1, and I'm finished. So 10 equals 2 times 5. And prime factorization of 20. Again, the smallest prime is 2. The smallest prime again is 2. And the smallest prime is 5. So 20 equals 2 times 2 times 5. Okay, fantastic. So now what? You are going to circle each different factor where it appears the greatest number of times. So if I take a look at my 2's factor, I have 3 2's here, I have 1 2 here, and 2 2's here. I want it where the greatest number. So I want all 3 of these. Okay? My next common factor, or my next factor, I don't have any 3's or 4's, but I have a 5 here, and I have 1 5 here. It doesn't matter which one I circle, but I'm going to go ahead and circle this one since it comes first. And what I'm going to do is I'm going to take these 4 factors, 2 times 2 times 2 times 5. Well, 2 times 2 times 2 we know is 8. 8 times 5 is 40. So 40 is the least common multiple. If I wanted to prove it, making a list, we'll go over here to this blank page. I have 8, 10, and 20. So 8, 16, 24, 32, 40. Well, I know 40 is a multiple of 10. 10, 20, 30, 40, and 20, 40. There is my least common multiple using a list. So you have 2 options. Use the list method or use prime factorization. Circle each factor where it appears the greatest number of times. So I have 3 2's for 8. I have 1 5. Multiply all of those together, and that gives you your least common multiple. Okay, that's it for chapter 4.7. For example 2 or quick check 2, I want you to use prime factorization to find the least common multiple. Give it a try and see how it works, okay? And we will go over any questions the next time I see you.